Cool. Now, if you remember in the last session, our focus in portfolio management topic is currently in the last two session is to calculate the expected return of individual stock and expected risk of individual stock. Okay. So we're still in step one and step two. Even this session is not going to be, as in this session is not going to be interesting. Last session was pretty good, but this session is not going to be interesting because in this session we'll try to understand the tools which is required as per the certification, as per the curriculum to calculate the standard deviation and return. Because you don't have or you will not have the time to calculate the standard deviation in this way. Okay, but I will spend few minutes on the calculation of the standard deviation. You can do this calculation on Excel as well, or you can do this calculation the way we did in the last session. But it is important that you should understand that how you can do this calculation on BA2 Plus calculator. Okay, so this session is not going to be very interesting, or we are not going to jump directly into correlation. We'll spend some time on the calculation of return and risk. Okay, so if you want to skip the session, that is up to you. In this session, what we'll discuss the usage of BA2 plus calculator. We'll discuss about that how we'll calculate the standard deviation for the population, for the sample. What is the difference between the two? We'll understand if probability is given, then how you would calculate the return and how would you calculate the standard deviation. Okay, so if you think that you already know these concepts, then definitely jump into the next session and skip this session. Okay, just a kind of a recap that how we calculated the standard deviation. And I did that calculation on an Excel. Definitely, this calculation on Excel is not going to be fruitful because at the end you have to use BA2 plus calculator. Okay. So don't worry about what we have done or what we are doing on Excel. Just it's a kind of a recap. So before moving into BA2 plus calculator, you have kind of a sense that what we are doing and why the standard deviation would, the number that will come on the BA2 plus calculator may differ. Okay. So the return of the stock was 3%, minus 4, 0, 2, 10, 15, and minus 8. Here I have applied the formula of average, and taken the number, and the average we got was 2.5714, and the same produced by Excel. Then the second step is to find out the deviation from the mean. So 3 minus 2.5714 minus 4 minus 2.5714, so and so forth. Then whatever the number you got, what you'll do, you will do the square. Okay. Then you sum it up, sum the value, you will get this value. So actually, we are at the state or the stage where we did xi minus mu whole square. So the sum will come as 371.71429 percentage square. This is in percentage square. Then you will take the average because on an average deviation from the mean. So you'll take the average, divide by 7. You will get 53.10204 average of this or average of this, and this is your variance actually. This is the variance. 53.10204 is your variance. If you do the square root of this variance, square root of the average, you will get what? Standard deviation. Okay. I actually, in this cell, what I did square root of average. In this cell, I have calculated the average. Now, in Excel, these are the basic sum and average. Till in these three cells, please understand, in these three cells, I haven't applied any uh, pro level function to calculate standard deviation. This is standard deviation. What I did sum. Okay. The basic sum function in Excel. This is the basic average function in Excel. And this is the basic square root function in Excel. That's it. But in this cell, I have applied a formula that is std dev dot p, standard deviation dot population. Again, it is coming to 7.287114. This is that formula. So Excel will apply this formula, but on what? Here I will provide the Excel these series of number 3 minus 4 0 2 10 15 minus 8, not this. I know this is not required as per CFA curriculum, but or any other curriculum, but when you're trying to find out the standard deviation, you're trying to find out the standard deviation of this. So what I want to say that you don't need these two steps. You don't need this step or this step. In Excel, you can directly use std, it's in capital, dev.p, and you give this series, you will get the standard deviation of the population. But there is something written as standard deviation of the sample. So in Excel, you will have std dev dot s for the sample, and it will give you the standard deviation of this series, assuming this is sample, not the population. I may not be able to enter into the discussion of the population and sample in the portfolio management discussion because it is hardcore statistics. But in a very layman term, if your data is everything about that entity, if 3 minus 4 0 2 10 15 and minus 8 is the return of the stock, all the historical return of the stock, then that is a population. But if you have taken a small subset from that population, then it is sample. So you have to apply the standard deviation formula for the sample. And in sample, the formula is standard deviation for sample formula is summation of xi minus mean again. I'm not getting into the notation of the mean because even that would be different upon n minus 1. And it is denoted by Sx. The population standard deviation is denoted by sigma x. So what I'm trying to say that this is the notation for the standard deviation for the population would look like sigma x, and the standard deviation sample notation would look like Sx. Okay? With that, we can jump directly into what? BA2 plus calculator and start using the BA2 plus calculator. Okay? Why there is n minus 1? There could be a thought that why there is n minus 1, why there is not n minus 2. We discussed it thoroughly in our quantitative analysis live sessions. Okay? Okay. So let's jump into the BA2 plus calculator. So this is our BA2 plus calculator. So let's make it vertical. So this is BA2 plus calculator. The first thing that you should do is to click this button second and data, and then do second again and clear work. Second data, second clear work. Second data, as you do second data, you are informing the BA2 plus calculator that you have to take the data. And when you do second clear work, then you are asking the calculator to delete whatever the data already stored. So it's asking about what is your first data point. It was 3. So you would press 3 and then do enter. And then you do arrow down, you will get Y. There is no Y in this data. There is only X. We are talking only about one stock. There is no two stock or three stock. So X is given to the X is the first data set, the first entity. That is X. We don't have the second entity. So we'll skip it. Arrow down. What was X02? What was X02? Let's see. What was X02? X02 is minus 4, then 0, 2, 10, 15, and minus 8. Okay. So X02 is 4. Enter. You need to press enter, arrow down. Then again it is asking for Y. We don't have another entity. Then after 3 it was 4. Oh, even it was not 4, it was minus 4. So we'll again press 4, and there is a button, there is a key which says reset plus minus. Just do minus and enter. Arrow down. Then what is the third data point? The third data point is 0. So you enter 0, arrow down. Fourth data point is 2, enter, arrow down. What is the fifth data point? The fifth data point is 10. 10, enter, arrow down, arrow down. Then what is the sixth data point? Have a look. Sixth data point is 15. Enter, arrow down, and the last data point is minus 8. So 8, then reset, enter, arrow down. Now to check whether whatever you have input to the BA2 plus calculator is correct, just do arrow up, minus 8, 15, 10, then you have 2, then you have 0, then you have 4, minus 4, and 3. Okay. So once you have validated, okay, whatever you have input into BA2 plus calculator is correct, just do second, and there is a key which says stat. Just the key which is saying 8. Skip this, it's not important. Arrow down, it's saying how many numbers of data point you have. So the number of data point you have is 7. Arrow down, it's talking about the mean, that is 2.5714. Even we calculated the mean as 2.5714. Now SX. Now tell me whether this is the standard deviation of the sample or the standard deviation of the population. The notation is SX. So this is the standard deviation assuming the data is sample. You don't know whether the data is sample or not. So in the examination or in the question, it should be mentioned that whether the data is sample or population. It should be. Then arrow down. Then this is sigma x. This is the standard deviation of the population, assuming that the data is the entire set of the entity. So the return data is the entire return set of the entity. Okay, so you got the standard deviation. Definitely we have other information provided, but it's not of our use for the time being. So you should understand that in examination, when you sit for the examination, you should know how to use the BA2 plus calculator to get the standard deviation, because there is no point following these steps and calculating the standard deviation, and you won't have Excel. So you cannot put down the formula like equal to standard deviation dot p and you will get the standard deviation for the population of the sample. This is one. It's good that we have completed the usage of BA2 plus calculator. But there are some questions where in the calculation of the return and risk, they will provide you In the calculation of return and risk, they will provide you the probability. And if probability is given, then you cannot use first the BA2 plus calculator. You cannot use Excel because the maths changes. The maths is not for return. The maths is not mean is equal to summation of all the entity divided by n, or the risk is not standard deviation summation of x minus mu whole square upon n square root or n minus 1, whatever. The mass changes because when the probability is there, when the probability is given, the mean formula changes, the standard deviation formula changes. Why it changes? We discussed it thoroughly in quantitative analysis. So we'll kind of recap about it. So mean formula becomes summation of probability into entity value, not 1 by n. Why not 1 by n? What we discussed in quantitative analysis, it's not 1 by n because when you do 1 by n, if you break this formula, if you break this formula, summation of xi upon n, if you break this formula, you're doing x1 upon n plus x2 upon n plus x3 upon n, so and so forth, xn upon n. So actually, if you see carefully, there is 1 by n, 1 by n, 1 by n multiplied to all the x values. And 1 by n has an assumption of equal probability. What does it mean? It means that the probability of 3 occurring or minus 4 occurring or 0 occurring, 2 occurring, 10%, 15 and minus 8% is equal. That is 1 by 7. And that's why you're using the formula summation of xi upon n. But in real world, when you use the subjective return, so there could be a subject matter expert and he will say that, okay, there is a 30% probability that the return would be 3%. There is 20% probability that the return would be minus 4%. There would be 5% probability that the return would be 0. There would be a 5% probability that the return would be 2%, so and so forth. So you cannot apply this formula. This formula would be incorrect. Or this formula would be incorrect because in these two formula, there is 1 by n hidden. See, even in this formula, 1 by n hidden. Even in this formula, 1 by n is hidden. So you have to remove that 1 by n and make it what? Probability. So 1 by n is stating what? Probability, equal probability. But now we are saying no, you cannot use the equal probability assumption. So therefore, the standard deviation formula would become what? Would become there is no 1 by n, or there is no 1 upon n minus 1, because the probability is being stated. Okay? So the maths will change. So let's take the data. It's 3 minus 4, 0 to 10%, minus 8%, 0 to 10, 15, and what's happening? Okay. So so this is my data. But now these data is being stated with probability. Okay, with probability. So you will have probabilities. So probability of say 3 happening is 10%, minus 4 happening is 5%, 0 happening is also 5%, 2 happening is 10%, 10% happening is again say 10%, 15 happening is again 10%. So so it is 40 and 50. So and minus 8 happening is minus 8%. So now you calculate the expected return. When you calculate the expected return, what you'll do? You will do the summation of probability into the return values. So you do probability. So you do probability into the return value, or you can just write it down the return as xi. It's up to you, whatever the notation you want to use. So 10 into 3% will become zero point 0.3. 5 into minus 4% will become minus 2. Will become 0. Then again, this will become minus 2. Sorry, positive 2. This will become 1. This will become 1.5. This will become minus 4. And then you sum again. So minus 3 plus zero point 0.2 is 0.5. 0.5 plus 1 is 1.5. 1.5 plus 3 minus 1. And the answer will be minus 1.2. Well, let's check the values. So zero point 0.3 plus zero point 0.2 plus 1 plus 1.5 minus 4 and minus zero point 0.2. Yes, it's 1 point. That's mean. Now you got the mean. So now the new mean is minus 1.2. So if you want to calculate standard deviation, so now you do xi minus the new mean, that is minus 1.2. So it would be 3 minus minus 1.2. So it will become 4.2. Minus 4 minus minus 1.2. So it would be minus 4 plus 1.2. This would be minus 1.2. So and so forth. And then you do the square and then you do the under root. But you will never do 1 by n. Okay? So this is important. So let's do the maths. Let's do the whole calculation because it's important. Otherwise, you will do silly mistake of doing the summation and then divided by n. There is no divided by n now. Why? We'll discuss about it. So right now you're doing x minus mean. So 3 minus minus 1.2 become 4.2. Minus 4 minus minus 1.2 is 2.8. Okay. 1.2. 2 plus 1.2 become 3.2. 10 is 11.2. 15 is 16.2. And minus 8 is 6.8. Okay. And then what do you do? Then you do the square. Then you do the square. So 4.2 whole square. So you do 4.2 square That will become 17.64. 2.8 square, that is 7.84. 1.2 square, that will become 1.44. 3.2 square, that will become 10.24. Then 11.2 square, that will become 125.44. And 16.2 square, that will become 262.44. And then 6.8 whole square, that is 46.24. Now you sum it up. So 46.24 plus, so 46.24 plus 262.44 plus 125.44 plus 10.24 plus 1.44. Now this is wrong. Why this is wrong? Because you cannot sum it directly. You cannot sum it directly because if you see the formula, it is pi into xi minus mu whole square. So the next step is to do the multiplication with the probability. So 10%. So now what you will do 10% into 17.64, 5% into 7.84, 5% into 1.44, so on and so forth. So the 10%, so you do probability, make another column and say probability into xi minus mu whole square. So the probability is 10%. 10% of 17.64 is 1.764 percentage squared, definitely. 0.05 into 7.84, 0.05 into 7.84 is equal to 0.392. 1.44 into 0.05 is equal to 0.072. Okay. Then you have 10.24 into zero point 0.1, that is 1.024. Then you have 1.2544. Then you have 2.6244. And then you have 23.12. Now you sum it up. Okay? So previously when we are doing the summation, that was incorrect. So you can see how anyone, even with experience, can do the mistake because our mind is ingrained to do the calculation in certain way. We forget about the probability. Okay. So do it 1.764 plus 0.392 plus 0.072 plus 1.024 plus 1.2544 plus 2.6244 plus 23.12. The summation is coming as 30.2508. And if I state it correctly, this is the variance. Now, if you do the square root of 30.258, if you do the square root of 30.2508, that will become your standard deviation. So let's do it. And it is coming as 5.50%. So the return is negative 1.2% and the standard deviation is 5.50%. 0.50% if the probability come into picture. Now, definitely the probability could be different. So this session was important because we cannot jump directly into the covariance or correlation without telling you the applications. Because in the question, there is a very high possibility that you will get the probability for the returns. And it is definite that you have to use the BA2 plus calculator. So I know the session is boring, it's pretty boring, but these important points need to be discussed. So the assignment is you have the probability 10, 5, 5, 10, 10, 10, and 50. You have the stock return. Now use Excel and try to find out whether the return is coming as minus 1.2% and whether the standard deviation is coming as 5.50%. Definitely in the next session, we'll jump directly into the covariance. But it is very important that you understand the probability usage in the calculation of return and standard deviation because it will come again when we'll discuss covariance and correlation calculation. Okay. So we are done. The best part is in the 3 session, we are done with step 1 and step 2. Okay. So that's the assignment. With that, thank you. Have a nice day.